My name is Eric Moratzka. I'm really happy to join you all here from the heartland in Texas, right down the road from Texas A&M University. I am not an Aggie. I'm married into this craziness of being an Aggie by marriage. But I wanted to spend quite a little moment here on the starting picture. It's not just a pretty marketing picture. It's actually quite descriptive of what Intelligent NanoFiber, doing business as Infi, is all about. We are in a lot of different sectors, and I know you mentioned at the start about being dual use. We're actually about quad or quint use right now, but because we're so small in a startup, I had to kind of pick my targets where there's revenue possible and what are the lowest hanging fruit. So although there's a lot of different industries that we can focus on due to the nature of the material that we're focused on, we're focusing on two, first of all, which is an oil sorbent and air filtration. And in light of the time constraints today, we're really just going to talk about air filtration. But I gave you the full slide deck. So if folks are interested in the oil sorbent area, there's some slides on that and my contact info, and I'd be happy to go into that. So next slide, please, Yuval. Intelligent NanoFiber. We are a spin-off from a 501c3 that a gentleman that I met at a business school started. I'm prior Air Force with a religion degree and a lifetime doing computer technology. So naturally, I went into the biotechnology area, right? That's just a natural fit for me. But we are in College Station, Texas. And the 501c3 is just a bunch of companies that we are helping to come to market. And what Intelligent NanoFiber does is we have a unique patent on developing nanomaterial from polypropylene. Now, there are quite a few out there, but our flagship offering is a unique nanomaterial based on polypropylene that we make in a patented way. And based on the way we make it, it has a lot of attributes that lend itself to a variety of industries. That's not the only offering we have. We're also doing some chemical engineering with unique components that deal with marine cleaning and releasing oil from rocks. But for today's focus, I want to focus on our air filtration. But the crux of our company is we're trying to solve big problems by going small. And John Wooden had a great quote, the legendary coach of UCLA basketball: if you do enough small things right, big things can happen. Next slide, please. So what is Intelligent NanoFiber? It's a hyperblown polypropylene. That's the unique process. We've got a unique nozzle and unique air gas stream that creates these fibers. So the way nanomaterial is created is usually some type of polymer. In our case, it's polypropylene, is melted. It's called melt blown. There's also spun bound, but ours is melt blown, and you melt it down and you extrude it. You can either do it at high velocity or you can do it under extreme pressure. And that's what ours is. It's extreme pressure, but low velocity. So the resulting fibers are about 400, it could be down to 300 nanometers in diameter, but about 1 to 2 meters long. So the resulting collection sort of looks like cotton candy. The background behind you is actually a sheet of our material, and you'll see that the water beads up on it. It's incredibly hydrophobic. It actively repels water, both physically and chemically. It just repels water. At the same time, it's oleophilic, which means it attracts oil, which makes for a great oil sorbent. Additionally, it's very manipulative. You can manipulate it quite easily, as well as being cost effective to make. So it is a fantastic air filtration membrane, and that's what we're going to focus on today. So Deval, if you could fast forward to slide 8 now. So that's all the oil stuff. So air filtration, if you continue building that, Deval, we all are familiar with life as we know it now with masks. There are crowds of people in masks, kids in masks, and people making masks that aren't very effective. Next slide, please. But we make a very effective filtration membrane, and clearly the time is right for jumping into this market. It's a great particulate filter. It removes particles about 1,000 times smaller than charcoal-based filters, which is really the gold standard from when I was in the Air Force. And I remember the gentleman on the call was in the Air Force. Remember those charcoal-filled suits? Those are the canisters that block out a lot of CBRN threats. Our material is fantastic for filtering all those particulates, including COVID-19, and we've already tested it at extreme results, which are very encouraging. We also working with a partner that can create nano pockets that, if you think of a forest in the winter, it's easy to see through the trees. But what he does is he makes that forest of trees in the spring with a lot of foliage, and it's it's easier to collect the particulate without impacting the air flow. So in terms of wearing a mask, the breathability. We also have a unique technology where we can make our material change colors, and it's customizable up to currently 42 different contaminants. So if you think about the canary in the mine, the canary can be the mask you're wearing. So if you're a miner down in, say, Chile, you want to be alerted if there's carbon monoxide that could kill you. So not only will the mask protect you, it will alert you, or alert you of maybe your guy working next to you. It could maybe say turn yellow and alert you that there's a contaminant in the air and you need to leave. And we are currently testing that.
15-second warning.
We're currently testing that for the U.S. Special Forces Command. And it also has a technology that we can embed it and make it self-decontaminating. So if you can imagine a mask that will visually alert you, protect you, and also decontaminate viruses, that's what we're making. Huge market, 7 trillion and growing. I think that's all we need to say about that. Mother Teresa had a great saying to close that if you do small things with great love and great care and think about how it impacts others, you can change the world. And that's kind of what we're shooting for.
Wonderful. Thank you so much. Let's open up to questions.
Can you talk a little bit about unit economics? So how much does it cost to make one of these filters and how much can you sell it for?
I'm a little embarrassed to say it, but, and I don't say this flippantly, it's pennies, it's plastic. You extrude it down. The real challenge we have is scale. And I guess that's the challenge a lot of us have. And I'll give you an example of a real world that we're trying to solve is a Finnish company contracted us to work on filters for a machine that will analyze breath to determine diseases, including COVID, and it uses algorithms to do that. So our filter is going to be used as the exit filter. Their first order out of the blue was 10 million units. So that's a real shock when I've got 5 spray guns that can make this. To how do we put this in large scale machines? So the economics is your question. That's going to make it cheaper once we have the early investment to put it on these machines, to retrofit these machines. That there are a lot of different machines that make nanomaterial. It's nothing new, but our nozzle is patented, and the way we get it onto various mediums or just spray the loose fill, and how you then air lay it with 3-ply is really the standard for masks. Some type of breathable outer layer on both sides, and then put our material in the middle as the filtration. So it is very cheap. I'm a long-winded answer, sorry. It is very cheap, and you can sell the masks for a lot of money, depending on the standard you're testing it to. That's critical. And I've just come back from Minnesota last week working with another test lab. We've working with a number of test labs, and there are a ton of standards out there. For example, the Europeans don't like adding electrostatic charge, which can increase your filtration effectiveness without impacting the airflow. The Europeans don't like that. But NIOSH standards here, they don't have a problem with that. So you're talking N95, N99, HEPA 13, MERV 13, there's all kinds of standards, and they all have different airflow rates, different micron sizes for the particulate, and all of that impacts the economics of what those masks sell for in the marketplace. I hope that answers your question, James.
Yep, thanks.
But the margin is vast. The real challenge right now, besides scale, is actually the raw material. Polypropylene is getting a little tougher to come by, but we're fortunate in that one of our sister companies that came out of this 501c3 is an injection molding company, and they deal in mass quantities of plastics like polypropylene.